right. Thanks for coming to my talk. My name's Tim, and I work at a company called Perspective, where we are building the next generation of browser-based data analytics. So just some background. Today we're going to talk about high-performance programming for the web. I'll be talking about why we made Perspective and what it's good at. What this isn't, though, is a Spark tutorial. We'll be using Spark to stream data into Perspective, but I'm assuming some baseline level of Spark knowledge here. Just a note, Perspective is fully open source, Apache 2 license, not open core or any of that, so it's totally free, no strings attached, right? So the background behind this is there are a lot of web frameworks and data visualization tools out there. These are just a few examples. Each one has different architecture, different trade-offs. Chances are some people in this room have probably used at least one of these. But despite all the tools out there, despite the abundance of tools, some things can still be a little clunky. Not to speak ill of any library in particular, but even when you're using some of the more advanced tooling out there, you can accidentally end up with kind of a bad user experience at the end of the day. The way we see it, there are three major pain points. Virtualization, which if you haven't heard of that, it's just when you have a table that has a large backing data set behind it, too large to show on screen. Rather than paginating, you can let the user scroll infinitely and load in like chunks of data as they scroll. What we call dumb grids are just really just the super simple grid components you've probably used at some point. Streaming is just real-time data. So to dig into virtualization first, we've probably all seen this. It's not a very good user experience, I would say. If you've ever used eBay and sorted by lowest price, and you gotta go through a lot of pages before you get to relevant results, you know. It's a lot nicer of a user experience to be able to quickly maybe sort by one category and then scroll to the part that you care about. Obviously, it's not a silver bullet. If you have a really large data set, you're going to need sorting, filtering, aggregation. But if you don't have big data and you only have not billions of rows, but thousands of rows, it can be really useful. Also, pagination gets weird when you have streaming data sets. So especially the size of the data set can change. You could have 6 pages, and then 3 pages, and then 1 page, and then 6 pages again. And trying to paginate through that while it's streaming just doesn't make any sense, right? Also, most of them don't support virtualization out of the box. Like you would have to do it by hand. So next is dumb grids. There are lots of them out there. They're just really simplistic grids that maybe only have like really basic sorting and filtering. But even the sorting and filtering they have might start to break down when you have complex data types. Like if you have a date time, if it implicitly sorts on like alphabetically, you change your date format from year, month, day to month, day, year. Now the dates are sorting differently, right? And even like really basic things like that can get tricky with some of the more basic data grids out there. Some of them might support Spark charts, some of them might support pivoting, but it's definitely not a given, right? And then on the other end, even if you use some of the more advanced tools out there, you can end up in the situation like this screenshot where you kind of have a low density of information, right? A lot of blank space, a lot of space taken up by configuration. And then the thing that you do want to see, right, the labels on the left have ellipses to make space for all the blank cells next to it, right? And so obviously you can fix that, but there's less out-of-the-box functionality too. Like you basically end up having to implement some sort of data engine behind it. And it doesn't just work out of the box for you. The other kind of dumb grid is grids that are just kind of an explosion of every way to visualize the data thrown on one page. These are kind of vanity charts. They usually are pre-configured by like a power user or a developer or someone. And the problem with these is that there's no way to explore the data. You can only really show things you already know. And if you experience a new problem, like if you have some novel visualization that you use to uncover some bug, it won't necessarily help you with the next bug. You won't learn anything new with it, right? It's kind of retrospective. So, and then the final pain point is streaming. Streaming really just makes every single point before this more complicated. It compounds the complexity of every part of your system and brings along with it its own inherent domain of complexity. So, and then on top of that, once you've implemented it, how do you manage end users, each pivoting the data in different ways? They might aggregate different things, have different computed columns, all multiplexed over a WebSocket. And then things can get hairy really fast, and it's rife with concurrency bugs. So here's an example that we took from the Fast API documentation. It's pretty much just a simple chat server, and we're just going to go through this real quick. You don't have to understand all of it, but basically, it's just creating a simple form for sending messages. Then we create a WebSocket, wire up the on-message side to listen for server-side broadcast, and then we create DOM elements for every message we receive. And then on the other side, we have a send message function that, whenever you submit the form, sends the data back to the server. On the server side, we just keep a list of active connections, and whenever it receives a message, it goes through all the other WebSockets and broadcasts it out to them. So next, we pretty much just set up the routes and handle the connections here. And that's kind of a lot of code for a pretty rudimentary app, right? Because this doesn't even handle a lot of weird cases with chat apps, right? You can't even see history. If you join, you can't see all the old messages. You can't scroll back up or anything, And if two messages are sent at the same time, it might show up on different users in different orders, right? It may not be ordered consistently across all users. And really, just that's kind of a really simple problem. And then what we're trying to solve is streaming pivoted data sets and lots of connected clients. And so it just gets really, really complicated fast. And thus, perspective. So perspective is a library that was developed at a bank for banking purposes. It's this interactive component you can stick in your web app. And basically, it's really good for large data sets. It also handles streaming data and static data sets as well. The main thing is that it allows your user to explore the data that you put in front of them. So it's not just some static visualization that the user can't really do anything with. Some key information about perspective. It's at its core, there's a UI and a C++ data engine that we have in this library. We compile the C++ engine to multiple platforms, even WebAssembly. So if you use the client-only architecture, we use the WebAssembly C++ engine plus the UI component, and it all just runs in your browser, and it's very simple. If you have more complex needs and you want a client-server architecture, we also compile the exact same engine with the same behavior, same performance characteristics, right? We take that same engine and compile it to native and run it as a Python library or a Rust library or whatever you want. We also, the entire web component, component is built using web components. That's just so that we aren't married to a particular framework. If you use React, Vue, whatever, you should be able to consume this. The configurations are JSON-based. Basically, whenever you're clicking around and pivoting the data in different ways, it's changing an underlying JSON config for every change you make. And you can then take that, save it, persist it, and restore it later if you want, potentially on a different machine. So we also have a bunch of built-in UI plugins, but you can also build your own. There's a plugin system. We have grids, scatters, bar charts, etc. we have fast virtualization with view windows, so we know ahead of time like what columns you're going to be able to see in the viewport. We know how many rows you're going to be able to see, so the data is stored in contiguous C++ memory, and we only take the snapshot of that little rectangle and marshal only that to JavaScript for viewing in the data grid. We also calculate deltas. The C++ engine will calculate deltas when you do updates if you have subscriptions, and it will send those as a binary arrow blob. And we also support a client-server. Client-server messaging protocol is coming in the next version of Perspective. It uses protobuf, so you should be able to implement your own server if you don't want to use our C++ engine. So say you really like DuckDB or some other database, you can implement a Perspective server protocol on top of DuckDB if you want. And then we also provide ExpertTK, which is, if you haven't heard of it, it's an expression language that basically the key thing here, we use it for computed columns. The key thing is that it's safe to evaluate remotely. They can't like create infinite loops or like do any weird malicious things. So, Perspective. Let's run through some the main features using an example data set. I have slides for it, but I'm just going to demo it instead. Let's do this. Give me 1 second. So, well, I guess I should have mirrored, huh? I'll make it work. So this is Perspective. So when you scroll through this data set, this is the Superstore example. If you guys haven't seen this before, it's pretty much just a commonly used example data set for visualization tools. You can scroll through it, and while we're scrolling through this, it is in real time pulling the data out of the C++ engine and rendering it on the front end. And it should be pretty quick and snappy for you. We can do sorting and filtering. We can sort by profit, descending, and then we can see that the most profitable state was Henderson, Kentucky, or sure. And then we can take this and let's remove all the columns that we're not looking at. And then we can group by category. And you can see that it creates a tree underneath. So there's always a roll-up row. And then underneath it, there's the individual groups with their roll-ups. And it does nested roll-ups, basically. So whenever as you add more nested group bys, it just keeps expanding this tree. So let me do state. And then also state is more useful to have up here at the top. And so you can see that, yeah, so we can look at the state of California, see the numbers for the state of California, see for only office supplies and only binders. And if you hold shift and click, you can collapse an entire level of a tree and just scroll through that data. There's lots of nice little things like that. We can also take this view and basically, with the same exact configuration, switch to a tree map. And here you can see like the big squares are the states, and then the smaller ones are the categories and the subcategories. It's kind of hard to read without colors, so let's color it by profit. And here you can see California is the most profitable, but New York has a few sectors that are more profitable, and Texas is in trouble, I guess. And so if you take this, you can just choose any one of our UI plugins and visualize the same exact configuration, basically. And so another interesting thing with filtering, if we go back to the data grid and let's reset this. We can filter by, say, customer name, and we can set the value to be like Aaron. And yeah, and so we can do like really basic filtering like this. But the important thing here is that you can do much more advanced filtering using our expression columns. So here with ExpertTK, you can use regular expressions, you can lowercase a string, do whatever you want, kind of. So here I'm going to, let me do this real quick, I gotta put the microphone down. So here I'm basically just making a regular expression that matches on the case-insensitive customer name, any name starting with Adam. And if I take this and create it, I can then take that new column that I made and add it to my view. Just drag it in. And you can see that it's false for all these because it's Aaron. And if I remove my existing filter, you can see there's a new computed column with all these values. Most of them are false. There aren't many Adams. And if we filter by that column, well, now we have a custom filter based on a computed expression. And the cool thing with this is that we can then switch to, say, like an X bar chart, group by state. And here we can see the number of atoms per state. And, well, not some, we need to count. And yeah, we probably want to do row ID. And count. Those are all of our aggregations, by the way. So now the cool thing is if I take this filter and I want to see what proportion of each state is Adam, I can move the filter to split by, and you can see those little orange bars are atoms. And if I go back into this expression, and I just want to see how many names start with A, I can edit this expression, and as soon as I save it, it will recalculate the computed column and recompute the entire view. And that's it, right? Like this is like kind of the more basic use case of perspective. So that's the first demo. I had GIFs just in case, but we don't need these. So now we're going to do a full demo of Spark Streaming plus perspective. So basically, we're gonna, we have a Python script that will generate dummy data. It's supposed to be essentially like performance metrics for the bunch of different machines. So like CPU memory usage, stuff like that. What jobs are running, what state they're in, and utilization metrics. We're gonna stream that data, or we're gonna aggregate it with Spark Streaming. We're gonna feed it into Perspective running in a fast API server, and then we'll have a front end that visualizes the whole thing. And demo time. It's hard to use Amethyst with one hand. All right. So basically, this is the data generator. We're going to run a couple of these on a TCP socket, and then Spark is going to connect to each of these servers and stream the data into Perspective. So first, to get started, we're going to do this in a notebook. And then show you all of Perspective's notebook integration, then we'll move on and do a server version. So let's do that. I can't see. There you go. So we're starting up the Jupyter and the data server as a Docker container. All right. So we've got a couple of helpers here that just have like the configuration settings, just ports and host names and stuff, real basic. Here, if we just, here are the helpers that generate the data. So the machines data set looks like this. So we generate a bunch of machines. We generate usage by calling usage on the machine. It generates some fake data, and then we just call usage on the fake data over and over again to generate new fake data, like this. So first we're gonna make the Spark session. These functions are pretty much just creating Spark sources that connect to the TCP sockets. Again, this won't run yet, really, because Spark is lazy. We're going to create our perspective widgets and arrange them as a 2x2 grid. Let's expand this. And then here we go. So this creates the Fast API server that will receive the data from Spark and stream it into perspective. And this will kick off the job. So now we're running Spark, it connected to the server. We can see the data coming in. Right now we're only streaming at like one update every 5 seconds. So you can see it changing. We can change our view by assigning these fields on the widget. So we're just going to change one of these to a bar chart, and the other one we're just going to group it. And now if we scroll up, we can see that the visualization changed and everything's still ticking. And so that's great, but most of you are probably not going to deploy your Jupyter notebooks. So let's look at the actual server example. One second. All right. So here's the server version running. Let's dig through the code while it's ticking. So it's pretty much the same. We have this Spark session. The main difference is that we have the perspective manager. And what this does is, in Jupyter, you only have one client, you, right? And so whenever we're running a Fast API server, you have lots of clients all streaming data at the same time. So you want to use this perspective manager that pretty much just handles all the tables and views. It multiplexes the request and sends updates and stuff over the socket. It does all that work for you, pretty much. All the rest of the code is pretty much the same. Like, we make the data frames, make the tables. We give the tables to the manager to host. We give each table to the Fast API server to stream the updates into from Spark. And then boot up the server and kick off the Spark job. But this ticking once every 5 seconds is kind of boring, so let's increase the speed, since this is a high performance talk. So let's change this to 0.001 for the interval. Then boot this back up again. And now we have data streaming in much faster. As the JVM warms up, you see it get quicker. If I minimize this code, we can make new tabs. And so each of these has their own WebSocket. and they can pivot the data in however they want individually. So like I can go into this one and configure it and say, actually, I want a data grid, and it doesn't affect this one. This one is still pivoting the way that it wants. We can remove the group by and add the columns back. And yeah, and so admittedly, this is kind of our vanity dashboard. When you have the data jumping around like this, it's not super useful to look at. But the main point here is just to show that if you have performance problems with your data visualization, hopefully, like it won't be caused by perspective, basically. So like we can handle really fast streaming updates. We can keep rendering at a consistent pace, and it should be able to keep up with whatever data streaming data loads that you have, and I can keep creating new tabs if we want. But that's pretty much it for the demo. Let me close these. All right. So, yep, that's my demo. All this was developed and open sourced where I work at Perspective Co. We're developing next generation of data visualization tech. This is a link to the slides and the code if you want to scan the QR code. That's all I got for today. All right, thanks for coming.